on our Adept CIM center today. We're just going to have a go at turning up some yo-yos from wood. What we've got here is just an old leg from a piece of furniture which was no longer being utilized. We've got that clocked up into the chuck, and all we've done here is turned it down so it's nice and round and faced it off. So I'm just going to take one final cut. So to do that, I'm running Mark III manually. I've got a spindle speed in there of about 800. Start the spindle up, and I'm just going to use the keyboard to jog the axes manually. Take that away so that we can actually remove material and give ourselves a good starting point for the leg. So now we have some material ready to go. You noticed I've just cut it off a bit shorter, so we've got maybe about 80mm from the jaw of the chuck to work with. You'll also see I've changed the tools. I've set up a straight tool because we're going to come in here and put our pattern on the face. Then we're going to use a back tool to put a groove in the middle of the yo-yo, and also to do the majority of the cutting off, and we're going to write that into an NC program. The other thing we want to do is use the corner of the machine as the home position. So in Mark III, we're going to make sure we've actually homed the machine in both axes, which sets that point up as 0, 0. The next thing to do is to set or find the center of the material so that we can set up an appropriate offset or coordinate system. We're going to use a G54 offset, which in Mark III is saved under the fixtures table, so that we can reference the 0, 0 of the job back to the machine coordinates which we just set in the corner there. So all I'm doing is driving my tool into the face of the material. I'm looking for a center, so I'm going to do that first by just scoring the face of the material so I get a circle, and that helps me find the center, finding the center of a smaller circle each time until I'm convinced that I have the center or something pretty close. So let's call that center. We're on the material, we're in the center. So what that shows me now in machine coordinates is that relative to the 0, 0 that I just set in the corner of the machine, we've moved the axes this far. And what I'm going to do is configure the G54 values to match those numbers. And that will set up our offset for machining that piece of material. Now I checked to make sure that we successfully set up our G54 offset correctly. The easiest way to do this is to use the manual line commands, specify G54, which is the offset, then a rapid G00. Then we want to go to part 0, which would be X0, Z0. Send that command to the machine, and if we set our G54 correctly, we'll end up in the center of the material as expected. So back on the machine, we've brought that G code in on a memory stick. We go into auto mode in Mark Turn. We load up that information, the yo-yo face. Now Lazy Turn doesn't necessarily, or doesn't put in the G54, some of the other information which is critical to running the machine the way we've set it up. So it's almost always necessary to manually edit the G code after you've posted it from Lazy Turn. So I'm putting in a G28, which is a homing move, and then I'm calling up that G54, which is very important to put the machine offset in, since we're going to work in an offset from the corner. Then I'm calling up the starting position, and then finally here's the code that Lazy Turn wrote to do the actual machining. I'm just going to slow the feed rate down a little. I'm going to save that. We've got a bit of a preview on the screen here, and then we're basically ready to run this program. If it's the first time you're running the program, you really want to do it in a single block and step through it one by one. If you've run the program a few times and you're confident, then we're ready to run. You can see we've positioned the back cut-off tool well out of the way so that we can use this front face cutting tool in this position without any interference. Naturally, we can see the lines of code on the computer screen as the machine steps through. Then the machine's returning to home. A little bit of sandpaper is always going to make it look nicer if it's timber especially. We can always start the spindle and do that again some more later. But basically we now have the front face of our yo-yo. It looks like we've got a fairly rough piece of timber here, but that's okay. We're now going to use the back tool to put the grooves into the center of the yo-yo where the string would go. Now, there isn't an easy way to program this other than manually, so I've spent quite a bit of time testing and checking and writing lines of code one by one to do a groove with the back tool. First step was to set up an offset, and we've stored this under G55 so that we don't have to delete our G54, which we used for the first tool, which means we can always come back to it. I have to make sure the spindle spins in the opposite direction, which is an M4 instead of an M3, and I have to make sure my tooling movements are in the opposite direction, which I've carefully done manually. So I'm ready to run this after much checking. Here we go. So I've programmed like a pecking cycle so that we're not just ploughing straight in to do a groove. We're grooving about 1 millimeter depth at a time. And that's just going to keep pecking in until it gets to full depth, which for that particular tool was about 18 millimeters depth. And it's going to make two grooves next to each other so that we get a 4mm wide groove, two widths of the tool. So that'll take a few minutes to run, but it's essentially the same pecking cycle over and over again until it gets to full depth. Just the grooving from a different angle. You can see the front tool is well out of the way of the chuck and the workpiece, so that we don't have to move it and we can successfully use both tools on the table at once. The next step in this program is to put in a cut-off groove. The cut-off tool will groove it as deep as it can, and then we'll cut it off with the last remaining bit with a handsaw. We'll then turn the job over and we'll face the other side to put the other face of the yo-yo on, and then it will be complete. So the grooving program has completed. You can see we've got the main groove for the yo-yo, and we've also got a groove which we can use to cut off. We'll do this by hand simply because our parting tool doesn't go deep enough. So we've cut our material and we've turned the job around, put it back in the chuck so that we can face the pattern into the other side. So we're going to run exactly the same program as the first face with the same tool in the same position. The only difference being that we've got a different G50 offset. We're going to use G56 to store the offset. So like before, all we do is drive the machine into the center of the material. Once we're happy we've found the center, we save the appropriate G50 code, and in this case I'm using G56, into the Mark III fixtures table to set that position, and then we're ready to run. Just have to make sure our program calls up G56 instead of G54 or G55, otherwise we'll be using the wrong offset. Here we go. Our spindle is now spinning clockwise once again. Right, so once that's finished, now we have ourselves a finished yo-yo. You can see I've wrapped some string and tied around there ready to go. Done a little bit of sanding. We could do a lot more finishing up if we wanted to. Basically, completed product, ready to go. Now that we've gone to all the trouble of writing the NC code, we could now make hundreds, if not thousands of these the same over and over again. It's just a matter of choosing your material, try and find a piece that if it's timber that's got a good grain structure, or maybe plastic, could even do it out of aluminium. And there you have it, quite a nifty little project for an Adept CIM center running Mark III software using a front tool and a back tool in the same setup.